This video is for lesson 39-1, using Venn diagrams to represent sample spaces. Learning goals are to use Venn diagrams and to connect Venn diagrams to probability. Here on the screen you see a drawing of a Venn diagram. It consists of overlapping circles and there's numbers written in different locations. The situation is, at Annabelle High School, some students take Spanish and some do not take Spanish. Some kids have art class and some don't. Let's let the letter S be the set of students who take Spanish and let the letter A be the set of students who take art. The number of students in the classes are shown in the Venn diagram. So the first circle is the kids who take Spanish. There are a total of 200 kids who take Spanish because the 112 and the 84 are both in that circle. The other circle has the letter A by it. It's the kids who take art. There are a total of 182 students who take art because the 84 and the 98 are both in that circle. You'll notice that the 84 is written so that it's in overlapping circles. That indicates that there are 84 students who take art and Spanish. And finally, you'll notice another number not in either circle. There are 56 students in the school who don't take Spanish or art. So a Venn diagram is a way to represent counts of data. We can use it to answer all kinds of questions about the situation. How many students take Spanish but not art? 112. How many students take art but not Spanish? 98. How many students take both classes? 84. How many students have neither class? 56. Because we can count things, we could also find probabilities. For example, let's say a student is chosen at random from all the students represented in the diagram. What is the probability the student has Spanish? Again, there were 200 students in the Spanish circle, so that probability would be 200 out of the total number of students represented in this picture. That could be found by adding up the four numbers you see in the diagram. 112, 84, 98, and 56 adds up to 350. So the chance that a student chosen at random has Spanish class is 200 out of 350. This could be reduced to 4 out of 7. We could answer many other probability questions using this diagram as the basis of our data. Skip ahead to number 3. Here you see a Venn diagram that has probabilities written in the diagram instead of counts. This makes it even faster to figure out probabilities. In the diagram, notice the probability 0.32 written in the circle for Spanish, but not in the overlapping region of the circle. The chance that a student has Spanish but not art is 32%. With a little bit more information provided, we could find out any missing parts in the diagram. For example, if the entire circle for Spanish is supposed to be 56%, we could figure out this missing piece here in the overlap section. 56 subtract 32 is 0.24. 24% of students have Spanish and art class. Skip ahead to number 4. The most popular color for vehicles is white. Suppose that a vehicle is selected at random, and let C be the event where the vehicle is a car, and W be the event where a vehicle is white. Some relevant probabilities are shown in the Venn diagram below. Question A, what two probabilities do you add to find the probability that the selected vehicle is a car? So everything in the circle with the letter C by it. We would add the 0.62 and the 0.14. So that probability is 0.76, or 76%. There are many other probability questions that could be asked and answered based on this diagram. What is the probability that the car selected is white? To get that, we would add together the 0.14 and the 0.06 and get an answer of 20%. Or, what is the probability that the vehicle selected is neither a car or white? To find that answer, we would add up all three of the numbers given to us, but then subtract them from 1. And that would find us the probability that goes out here, not in the circles. Skip ahead to number 6. Let's take a look at yet another Venn diagram situation. Suppose a student will be selected at random from that Annabelle High School. Let A be the event where the student takes art class and B be the event where the student plays basketball. Instead of actual numbers in the diagram, we have variables, but variables operate exactly the same way as numbers. You can add them, subtract them, whatever you need to do. Question A1. How would you calculate the probability that the student plays basketball? Probability is a fraction. For the numerator, you find out how many students play basketball. We want what's in the capital B circle. To find that, you would go Q plus R. Then, to get a probability, you would divide by the total. To find the total, you would add up everything shown in the diagram. P plus Q plus R plus S. Again, make believe these letters represent actual numbers. Skip to question 3. What's the probability the student plays basketball but does not take art? This time we don't want to include Q in our answer because Q is in the art circle as well as the basketball circle. Our answer would be R divided by the total. And again, the total would be P plus Q plus R plus S. Now take a look at question B. This reviews the concept of complement from the other day. If we know the values of P, Q, and R, that is, everything in the circles, how could we find the answer for S, the number not in the circle? We could start with 1 and subtract the P plus Q plus R. This shows that concept of complement, everything that's not in a particular event. Now go to number 7. Suppose a student will be selected at random from Annabelle High School. Let F be the event the student plays football. Let M be the event the student's in music class. Some probabilities are shown in the Venn diagram. So this Venn diagram shows probabilities in it, not counts of students. It's important to realize what type of Venn diagram you have before you start figuring out things about it. It says complete the diagram. So if the entire circle F is 0.21 and then this part is 0.18, we can use subtraction to find this missing overlapping section. It's 0.03. Now that we know the 0.03, we can add it to the 0.77 to find out that circle M is 0.80. Finally, the numbers that are in the circles add up to 0.98, and so outside of the circle must be 0.02. Now everything is figured out and we could answer probability questions, like question B. What is the probability the student plays football but not music? So only the number in football circle that's not in the music circle. That's the 0.18. So the probability is 0.18 or 18%. Question C. What's the probability the student takes music class? I'll pause the video for you to try that. The answer is 0.80, because in the circle representing music class, you would add the 0.03 and the 0.77. Let's summarize the lesson. We used Venn diagrams to help us count things and help us figure out probabilities. Venn diagrams are overlapping circles. There will be numbers in the circles, including the overlapping region of the circles, and there may be a number outside of the circles.